Hey everyone, I'm Brandon Konkle and welcome to my new channel Deterministic. Here I'll explore web development using strategies like type safety, category theory, functional and object-oriented programming, and more, but in a practical way that allows you to keep moving quickly. I've been a web developer for 14 years now, and I've seen firsthand how challenging it can be to keep a production application stable while still keeping up with the needs of the business. My channel will cover ways to make things more deterministic and less chaotic, helping you be more confident in what you deploy. So, my first video series that I'm kicking off today is going to talk through a production-ready GraphQL API with Node and TypeScript using the Nest.js framework. I'm going to cover a variety of topics, things like handling HTTP requests, working with a database, authentication and authorization, unit and integration testing, real-time events with WebSocket and Socket.io, and finally building and deploying. This first episode will essentially be my lightning talk about why you'd want to use a stack like this and what all the parts do. And if you don't really care about why and you want to skip ahead to the how and see how it's done in Nest.js, check out episode 2. So first off, why Node? For me, it comes down to flexibility and performance. JavaScript is a highly optimized, dynamic, interpreted language, and it could run almost anywhere. You can write a universal application that can run in the browser, on the server, on a mobile device, a desktop machine, an embedded platform. Just the opportunities are endless. So with that comes a lot of opportunities to share types and tools between platforms if you're deploying a multi-platform app or an API with multiple clients consuming it, for example. Also, serverless platforms like Lambda and Cloudflare's options that are coming out are really spreading and seeing widespread adoption, and they have Node as a first-class citizen. The single-threaded event loop concurrency model, it performs really well, it scales easily, it's easy to think through. Tools like Babel extend the language to provide modern ergonomics before it goes through the lengthy standardization process and patches things and provides fixes for common problems while working with it. And the rich ecosystem of tools that are available on NPM is infinitely useful. There's a lot of reasons to love Node as a platform, but there are also a lot of trade-offs too. Node is a dynamic language without a sophisticated built-in type system, so runtime errors are very common, and undefined is not a function is a running joke in the JavaScript community. The experience of building, maintaining, and debugging Node applications can vary pretty wildly depending on the platform it's deployed on or the tools that you're using to work with it, and there are often hundreds of different ways to accomplish something, so it leads to a lot of fragmentation and time spent looking for the right solution for you. With that, though, comes TypeScript. So I mentioned that Node doesn't have a built-in type system. TypeScript is an add-on to Node. It is something provided by Microsoft and refined by the community pretty heavily over the years. Remember the days when it was first launched and anything could be undefined? It's come a long way since then. And this type safety, really to me, it's about encoding your intent. You're able to add context around how you intend your code to be used, going further to prevent runtime errors and confidently handle complex logic because you're using strategies like category theory and type safety and static analysis to find bugs sooner and spend less time debugging runtime errors in production. Node on its own can be very unpredictable, which often leads to a much heavier emphasis on unit integration and end-to-end testing to try to tame the chaos and stop all that undefined is not a function madness. And type systems with a strict safe mode like Rust or Haskell go completely the other side of things. They go to great lengths to prevent operations they can't mathematically prove won't result in undefined behavior. So this can sometimes lead to days-long troubleshooting sessions trying to solve edge cases, all the edge cases, to unify the types. So TypeScript makes a number of compromises. They result in less soundness in favor of broad compatibility with existing JavaScript code and support for things like generic types and things to get control of some of those varying arguments and things like that. Anything that you can do in JavaScript, you should be able to do with TypeScript. But you might want to use TypeScript to constrain what you're doing to be more sound than what JavaScript allows on its own. That's where the encoding intent comes into. There's also a lot of opportunities for gradual adoption, chances to cheat the system to provide better usability by sacrificing more guaranteed soundness. The goal is to provide a usable balance between the endless edge case optimizing of perfect soundness and the wild unpredictability of fully dynamic code at a large scale. But the trade-offs are, since cheating is easy, there can still be a lot of unpredictable behavior. Some libraries may require some shimming in order to fill in types, but the definitely typed project definitely mitigates this quite a bit by providing types for a lot of third-party libraries. For developers unfamiliar with type safety, getting up to speed on TypeScript can be kind of overwhelming at times. There's a lot of concepts to wrap your head around, and the build tooling can be complex if you don't use a pre-rolled solution like something generated from a generator like NX, which I'll talk about in a little bit. I still think it's the best option we have available to us in the Node ecosystem, though. It makes the right compromises, but still gives you the tools that you need to make things really strict, as long as you don't have developers that take great lengths to cheat the system and cast things as any and things like that. So going along with TypeScript, I recommend the Nest.js framework. It's not my favorite web framework, but it offers a really good balance of strong type safety with deep customizability, using conventions that are familiar to a lot of people if they come from Angular or the .NET community or things like that, object-oriented influenced communities. It can be frustrating to wrangle the dependency injection system, but that dependency injection system gives you a lot of tools to extend your functionality in different ways, essentially providing middleware at different parts of the request lifecycle. Nest allows you to wrap almost anything with additional functionality, from individual method parameters to controllers and resolvers, all the way up to global guards and interceptors. And because of this rich customizability, there are a number of open source plugins and tools that have been shared and published for Nest.js. Many of these are really high quality and enable some pretty powerful abstractions on top of the framework. But everything has trade-offs. Decorators are everywhere, evoking strong Java Spring comparisons. Routing logic based on the global metadata system can be kind of indirect and hard to find a breadcrumb trail for at times. And like I said, that DI system can be tricky and tough to troubleshoot sometimes. And I've felt my blood pressure raising sometimes trying to debug it. I definitely prefer Microsoft's more straightforward T-Syringe tool, but that came well after Nest.js was established. So it's definitely provides great tools for what Nest is trying to do, and it's the best available in this ecosystem right now to hold on to that type safety and to share things among a big team of varying experience levels. You're not sure what they're familiar with, and so this gives you ways to constrain things and to wrap functionality in very convenient ways. So what about GraphQL? Why that? The built-in type system that GraphQL provides, the GraphQL schema definition language, that's what it's called. It leads to a variety of different ways to use it as a source of truth for automatic code generation. Tools like GraphQL Code Generator make it easy to define a contract of inputs and responses that you can share with other teams using completely different ecosystems. And that schema becomes the central source of truth that everything can be generated based off of. It also gives the backend rich detail to help optimize the queries, solving the n+1 problem, if you do the work to do it, in a really elegant ways, giving you ways to calculate really efficient joins with related data. And popular tools like Swagger and Postman aren't really even necessary because rich documentation is built right into that schema definition language, and tools like Playground or Postman actually make it really easy to work with. So this is my current favorite stack. This is what I've been using with client projects most recently, the most because I think it offers the best balance of features right now. I think there are some very interesting future stacks though. For example, I've got my eye on Rust with async GraphQL and maybe the Warp framework. I'll definitely explore that in future video series. But for right now, this is what I love to use to work with Node in production. So Along with this, I have a few preferred tools that I'll talk through, the first of which is NX. This is a really slick build framework, branching out from the Angular community and starting to spread out all across Node and front-end JavaScript. The major distinction to this is single package monorepos. So this is not the kind of monorepo that you'll want for managing a collection of packages that you publish to NPM and manage independent versions between them and dependencies and things like that. This is more, you want to structure your application as a monorepo, and this is going to be an executable thing essentially that you deploy. And so for that, NX provides a structure that has a single package JSON at the top of your repository, and that single package JSON applies to everything within it, all of your apps, all of your libs. NX structures things with what I consider to be entry points in the apps folder, and then internal libs, which are almost like internal NPM packages. The way that they configure tsconfig allows you to reference them as if they were a package. And so this is your reusable business logic that you can share between the entry points that are implemented as your apps in the project. And it provides a lot of built-in generators, things like if you've used Yeeman in the past to scaffold your projects and to add new components to your projects that plug into that top-level build system and provide a consistent way to build within your CI pipeline and prepare for deploying to various environments like production. There is a good ecosystem of community tools, lots of plugins that integrate with a bunch of different tools in the JS ecosystem, not just Node, not just React, which has always been my forte, but things like Svelte and Angular, of course, and all the different types of the cornucopia of packages that are available in NPM, like I was talking about. It's also provides some good conventions to unify building. Even if you've got a team with diverse tools or lots of teams with diverse tools, you can build them in a consistent way with something like NX. And it's been very handy as I've scaffolded new projects and got teams on the same page on things. Prisma is a powerful object relational mapper that I love because it uses strategies taken from the GraphQL community, things like schema first and code generation, to generate a really detailed type-safe client for your application specific to your database schema. So you work on your schema.prisma file, it generates migrations which you can then customize, and then you can access data in those tables using a TypeScript client with a lot of related features, things like joins that you can invoke automatically and that the type system is aware of, and that it knows each unique property or unique field that you need for the join. Just really intricate features for keeping your access to the database efficient and type safe at the same time. I love it. I definitely recommend it. Also, I love a tool called Castle for consistent authorization. You can use this on the front and the back end. It's a universal approach and I guess a shared language to use around authorization, where your user gets an app ability that defines all of the permissions, all of the actions they can take on all of the different resources, and allows you to filter those actions and define complex rules around those resources in a really intuitive way. So this can be used with your front-end teams on your React projects or things like that. There's a number of different plugins that are starting to pop up with this as well. And then I love Prettier. I love to stop thinking about style and just letting the formatter format it for you. I really, I just am amazed at the productivity gains by just not thinking about style and not reviewing PRs for style and not responding to PR feedback about style and nitpicking over opinions. And Prettier just eliminates all of that. And I love the standard JS style. This is a little bit controversial, but I go no semicolons because I love how clean it looks. But that's beside the point. Either way, use Prettier, format things automatically. Don't think about code style as much anymore. So beyond those tools, there are also a few important style decisions that you'll see within my repositories. They leap over a few hurdles that I've encountered when using these tools in production with larger teams of varying experience levels, like I was saying, and they just avoid some pitfalls that I've fallen into personally before. First off, named exports. I really like how they encourage naming consistency. Named exports are when you say export class or export const, and you export the name specifically rather than doing export default. And so that changes the way that you import it. And misnamed imports can actually lead to bugs. Like when I recently copied and pasted some code and forgot to change an import and thought I was importing my user factory, when in fact I was importing the profile factory and nothing made sense. It's still possible to rename an import, but with this named export strategy, you have to take specific effort to do it with an as expression, and you can see the breadcrumb trail. You can follow the explicit declaration there. The next important decision that I make that's more controversial is no barrel indexes. Barrel indexes are those index.js or index.ts files that you use inside a directory that pulls together all of the different pieces of all the components of your module that's in that directory in one convenient import. This is the strategy that NX uses to enable that library style interaction with the libs that are in the lib folder. But in this specific context of a GraphQL API or even just a REST API, but exposed through Lambda functions or something like that, especially if you have multiple entry points, there are a number of drawbacks to barrel indexes. With care and consideration, they can be used without issue, but using them correctly takes some pretty constant vigilance. For instance, I'll get into some specifics here. So accidentally using a barrel index within a module that's indexed by the barrel can really easily cause silent circular dependencies and result in imports that just become undefined. If you're in a module and you import something else from that same module using the index, all of a sudden you've got a circular import that is silent. It's deadly. Behind the scenes, it's undefined and you won't know why until your code fails at runtime. It's insidious. They can also cause you to import more than you need. Importing one thing from a package can result in importing many things, which could inflate the size of your bundle. This is something that serverless deployments are particularly sensitive to, but containers too. If you're deploying in Kubernetes or ECS or something like that, container size matters also. This is especially relevant if you're using an alternative packing tool like serverless Jetpack or something like that, that speeds up packaging, particularly for an environment like serverless. Also, even though they're not a best practice, you do see import time side effects. They're common enough in the Node world that they can become a real hazard with barrel indexes, and you might miss it. Simply importing one thing from one package can result in importing something else that initializes a service at the top of the file that you never even intended to use in this particular use case. And that can be a problem, especially in environments with multiple entry points where you only want to include the libraries that entry point is using. The downsides of no barrel indexes, though, are that the developer ergonomics are impacted. Rather than taking advantage of that NX feature where libs are really convenient, like an internal npm package, your import starts to look a lot more granular. Generally just one thing imported per line, maybe two. It's unfortunate, but it leads to more predictable runtime performance, leaner bundles or containers, and fewer runtime tricky bugs, unexplained, undefined to track down, stuff like that. And then finally, the last recommendation that I follow is decoupled entry points. So I mentioned before how apps are generally just entry points that lead to the libs. And you don't have to structure it that way. You can actually do a lot of business logic in your apps, but I prefer not to because I like to keep things decoupled and easy to slice apart. I like to start my services as a single application, and then as needed, if I need to slice off another part to host in a different way, or if I need a side Lambda function over here to respond to SQS events or S3 bucket notifications, or if I want to start embracing medium-sized or microservices and start to split it up into multiple domains, I can do that a whole lot easier if all of my business logic, all of my resolvers and controllers and things like that are in my libs. And so I'm just referencing them from my apps, and I can switch that reference to a different app if I want to. I can split them up however I like without actually changing much code. So we've seen the tools that I'm going to build with and why I'm using them. Let's talk about what I'm going to build. Our demo application through this series, and likely through a few to follow, will be Caster. It's a hypothetical tool to help podcasters, broadcasters, and streamers coordinate show content with their co-hosts and guests. The kind of thing that I would probably want to use if I started hosting live coding shows or something like that. It'll be limited to just the API to support the front end, and when I explore potential future platforms like Rust, I'll keep the features the same so that we can compare that developer experience like I was talking about. You'll be able to create and log into a user account, save a personal profile, create a show with episodes and topics to discuss within that episode, and present a live interface, highlighting topics and allowing participants to chat. All of the API features that would be required to support a platform like that. I'll start with the shell of an app, and that isn't complete yet, and we'll talk through architecture and patterns. We'll add new functionality, set up a build and deploy strategy. To follow along, check out the GitHub repository, Nest.js example Caster API. I'll link to it in the show notes. Let me know if you run into trouble. You can find me at bkonkle on the TypeScript or React-to-Flex Discord communities or on Twitter. All right, so that's my lightning talk about why you'd want to build this way. Hopefully this hasn't been too overblown and long-winded. Next up in this series, I'm going to talk about how to create and test GraphQL resolvers, how to map those GraphQL operations to services that work with Prisma data, using JWT tokens for authentication and authorization, integrating with application-specific roles and permissions, integrating with or introducing those WebSocket events, and deploying to AWS. I haven't decided. I think I'll probably try the Kubernetes K8s platform on AWS, but we'll see. I'll decide that later as we go. Let me know what you'd like to see. Thanks a lot for watching, and I hope I will see you on the next episodes. Thanks.